Nice thing is you guys didn't technically have to solve it, but was it possible to solve? And the answer was yes. Can you guys tell what ended up happening between here and here? This guy squared, got a common denominator, mushed it all together. You ended up having a denominator of x plus 1 with some constants, etc., with a square root that canceled out with that guy, and then you were able to do a quick little u sub and go. Final answer ends up being 49 pi over 3. So this is an integral that you could be asked for eventually on an AP, etc., to solve by hand. But you guys were just doing calculator, right? So 51.313. 51.313. Are there any arc length questions, first of all, before we just go ahead and focus on surface area? I think you guys only had like 4 of them. Any questions in arc length? Okay, so then moving on to surface area. Once again, let's do the basics before we get to the hard ones being the one we were working on in class yesterday. And struggle. It's still frozen, but that's all right. Okay, let me go ahead and get you guys going on number 22. They did it in terms of x getting a final answer of 6. Let's go ahead and grade and get the final answers first, then we'll go back. Because there were a few things yesterday that I wasn't completely happy with. Not with you guys, more with myself. Because that one problem I was like, wait, it should be able to be. And then we tried it and it worked. I think I made a general statement I shouldn't have made. Not saying it never can work, but saying it always works is dangerous. It was 14 point something, 453 or something like that. Yeah. Aryan recognized it. It wasn't his, but it was 1/4 of his, and there's a very specific reason why. And I think you got the 14.5 something. Maybe it was that. I just know it was 14 point something. I think I still have it in the calculator. 34 is D and 36 is B. Let me give you a second as far as the setup. Actually, I think I have it right here. 14.137 is what I got. Good, that's the right answer. Either one. Let me see. Well, because actually the second one is wrong. Did you do it with y's or x's? Oh, sorry.
Because my brain told me that my radius was x. It's just x. So when I did x with the derivative and by 2 pi, I got 14, which was my original equation. That's originally how I did it. And the only thing with my derivative was weird, so I had to do it again because my derivative was wrong.
Why? Okay, first of all, the book problems. Do you guys have any questions on the book surface of revolutions that we had to do? The evens or the odds? Anything from section 8.4? Yeah, go ahead. Go back. Oh, got it. Go to 57. I was like, wait a minute, it's not up there. Yeah, anything else besides 57? Okay. Naomi, you have the answer, what the answer is supposed to be, right? What page was section 8.4? Anybody have that? 457? Is 8 point... Oh, okay. So hold on, I'll just go find it here. 47, no, not 424? Oh, okay. Oh, bummer. So close and yet so far. Okay. Sorry guys, I don't know why it's so slow. This is brutal. 57? On 8.4? You sure? Oh, 8.3. Got it. So 8.3. $417, you said, Naomi? Oh, surface area. Was surface area 8.4 and arc length was 8? No. Surface area was 8.3? And arc length was 8.4? Anyway, I guess I'll just go for it without an answer. Find an area of the surface generated by revolving the curve about the... Okay, Naomi, what I see real quick, it's kind of confusing with the square root over here. But if we square both sides to try to think of who this is, it's really just y equals x squared. But we're only looking at the positive portion of it because the positive square root is 1/2, the negative square root is the other. It's just weird because it's flipped in our minds. Y is from 0 to 2. So we're talking about this region right here that's being revolved about the y-axis. There we go. So then in my mind, to make my frustum, I'll go a different color. In my mind, to make my frustum, you want to think about your band. And here's our band right here. And that just helps me as far as my radius, because I want my radius, there we go, to be a horizontal length. And so my radius being a horizontal length, I think I need to change this back. I could say S is equal to 2 pi times the integral. I see this being, in my mind, just for visualization's sake, I see it as being a dy, and that's kind of nice too with my y bounds. 0 to 2 and my function in terms of y. But to that end, if I go thinking about my radius is going to end up being, isn't my r x minus 0? So I would go ahead and plug in my square root of y as my r times my 1 minus, and now I need to take my derivative, which is just 1 over 2 root y, quantity squared dy. That's how I would have set it up. You would have ended up with a common denominator. Those y's would have ended up canceling. I think you would have gotten the square root of 2y minus 1 times... No, 4. 4y minus 1 all over. If you were solving it by hand. That canceled out with the denominator, but you had a 1/4 that you could have pulled out to be a 1/2. I think you would have just had pi. Is that what you would have ended up with as your final expression? How does that measure up with what you saw when you were checking it? I'm going to go ahead and get a decimal answer because that's what you can check in the back of your book, which would be pi times... Are we okay, guys? What's wrong? Sorry, what's wrong? What's wrong? Okay, then hold on. Let us problem solve this problem, okay? If you guys are bored, I have 2 BC, 3 books, and you have a review to be working on. Go ahead. What's up, Naomi?
Because we were just confused on why we used that formula, because it was 8.4 from something.
Oh, sorry. And that's what we've been saying today about how I was like, oh, did some of this get introduced in an earlier section? So yeah, we called it 8.4 because I wanted it totally separate from volumes. Your book decided to introduce it a little bit earlier. What I was trying to find out from you guys then, this is a surface area problem, right? Am I wrong? Okay, so 8.3 must have introduced surface area, and then 8.4, you guys can peek at those problems. Were those arc length problems? Okay. So our book was weird. They decided to cover surface area in 8.3 for a little bit, and then arc length in 8.4. But I think, like in a previous year, and I erased it this morning, and I probably shouldn't have erased it. right here at the end of your notes, which probably no one actually looked at when I saved it last night, it did say on section 8.3b and 8.4. I just went ahead and called it my own, like, brand new sections. Sorry about that. I didn't mean to confuse you. But I think the final, oh, sorry, now I just messed up. Justin, go ahead, though.
So, going back to 57.
Yeah.
What's the case, again, in which you can't use square root? Like, why would you not do something else instead of using that, like the function as your radius?
Well, if we were in terms of x, we'd just be saying that r is equal to x and be using y equals x squared as our function. But then we'd have to use x bounds as well, so we have to find the intersection. When y is 2, x would be, it'd be 0 to root 2, right? But I'm trying to plug this in and even see if it works. Hannah, go ahead. Or Deba, who's raising their hands?
I was wondering if I can get my notes out and I go through my login.
Yes. Why aren't they already here? Okay. So we have 0 to 2 of the square root of x times the square root of 1 minus 1 over 2 square root of x, quantity squared dx. Yesterday, Aryan, it was your calculator, right? When you were plugging in and getting an unreal answer, you were getting unreal and someone else was getting real? Is that how that worked?
It was because it wouldn't let me do the squared within the square root, which was like the easy distance. So I just put it as a negative power.
Oh, maybe that's what mine's doing too. So you did the square root under the square root and it didn't like it, but when you wrote it to the negative 1/2, it worked. Okay, sorry. I was trying to get you guys a decimal from my work. Naomi, did it match up with what you thought it was going to be?
What did you say?
Oh, okay. Never mind. No. Mine's giving the whole non-real answer that Aryan's was giving yesterday, but then I think it's because I was trying the square root under a square root thing with my calculator. Nope, it's still not working.
It says the answer was 13.647.
Huh. None of my integrals are working in my calculator. Has anybody else plugged this into their calculator and gotten an answer?
Yeah. So I got 13.490.
And what'd you say, Naomi? 13 point?
13.614.
Ooh. Which one did you plug in, James? The top one or the bottom one?
The bottom one, when I plug that in, I get error.
Uh-oh, that's what I get too. Okay, since I'm starting to lose all of your guys' attention, Naomi, thanks for bringing that up to my attention. Let me try to borrow someone's calculator a little bit as you guys get working on the review. Let me go and get pictures of the review because my 3 books are gone and some of you are like, great, I can't review now. Yes, that's what I was going to pull up before I totally lost all of your guys' attention. For the problem you guys were working on at the beginning of class, let me go ahead and pull up from notes. Let me see if I have it. For the one on the board from yesterday, I had to do a half and a half and a half. Oh, not from last year. Those would have been the two setups that you guys would have wanted to do for your volume and for your surface area for your back of your homework spiral problem. Yeah, and the integral, you got it? Yeah, the integral of x, 1 over x squared is x to the negative 2. And then we go ahead and solve. Now the nice thing is we don't need to all be distracted right now because we're all on the same page. We all tried this in the back of our homework spiral. So as far as the volume, it would just be disk method. That would be the easiest way. Shell method would actually be way more complicated. So a disk method, you could have just done your pi r squared, pi r being the function of top minus bottom. And then you get this expression as your volume for any cutoff b. And so if you guys just going ahead and going to letter C, if we were to take the limit as b goes to infinity of this expression, doesn't that go to 0? Which means, wait a minute, as b goes to infinity, isn't that of this entire infinite curve? So what is the volume of the infinite curve starting at x equals 1? Pi. Finite volume of an infinite figure. Right? Because as b goes to infinity, as the cutoff goes to infinity, it's talking about the entire thing. This is actually called Gabriel's horn. As you keep on drawing and having b go to infinity. Gabriel's horn has a finite volume. As b goes to infinity, the entire thing is pi. The volume converges to pi. Surface area is a little bit more complicated, though. Surface area, do you guys see how it's y minus 0? Y minus 0, you could plug in your function for y, 1 over x. You could go ahead and throw in your 1 plus derivative squared. Yeah, how to actually solve the integral, right? Well, I was saying one integral is possible to solve by hand, and one you might not have known how. Because at this point, you would have had the square root of... Oh, so I was saying you could take the square root of x to the fourth to be x squared. Yeah, 1 over x cubed times the square root of. If you brought it back under, it would be x to the 6th. So you could do a little like square root of x to the 4th over x to the 6th plus 1 over x to the 6th. But even then, you have a nasty square root. Long story short, you need something called trig substitution for that in order to be able to solve the integral. And trig substitution, I'm not going to show you before the chapter 8 test, but the long story short is after you do trig substitution, taking out the x's and actually getting this entire expression in terms of trig functions that can be manipulated and transformed like t-proofs, we would take the limit of the surface area and have it be infinity. All of that work is actually on a sweatshirt that somebody was using the other day. Oh, Melanie used it yesterday. Poor kid to sit on. Other kids used it as a pillow a few days ago. Here we go. Da, 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 da. Gabriel's horn. Volume, that equals pi. And a surface area, we actually, back then, there you go, equals infinity. Ended up putting everything in terms of y instead of in terms of x, and it made things a little bit easier. But I think we also stole that proof from online. But there's Gabriel's horn. He's kind of a cool one. And that was our very first BC sweatshirt, which was fun. But anyway, the question isn't so much for you guys, can you solve it by hand for the test, right? What's the question? Can you set it up? So speaking of can you set it up, those are the setups for A and B. That was the most important part for yesterday with this weird one. Not that I'm going to give you this weird one on the test, but just to understand. If it was in terms of y, which is the one that makes the most sense, I made a few mistakes yesterday at the very end, not the least of which was I was doing this entire hand. Problem is they stated, I underlined it twice, only between x is 0 to 2. So if x is only in between 0 to 2, then we had to do a couple things. Not only is my frustum not all the way around, so I had to take my 2 pi r and multiply by a half to get a half frustum. But it's also not for the entire circular portion that we were talking about between 0 and 3. 0 and 3 would hold in the whole thing. If you just go y is 0 to y is 3. The problem is I only wanted half of what would come in the 0 to 3, which is why we had to do another half. Aryan had gotten this one to be 56 point something something, and he realized that if he divided by 4, it would end up with our, no, by 8? It would end up with our, I've had too many numbers in my head. Maggie, what was it that you got yesterday? 14 point, yeah, 14.137 would be the final answer. Now, ironically, Maggie didn't get it using the in terms of y in form. She actually was showing me right before I came up to talk about number 57 that she had gotten it by 2 pi, the integral from 0 to 2. So thinking about it in terms of x, with only going from 0 to 2. I haven't wrapped my mind exactly around it. I did know that this one didn't work because this one going in terms of x, if you try to take a frustum in the other direction, the spherical portion isn't spherical. But maybe that's the reason why going from 0 to 2 is okay. Because if you're going the other direction, and if you're doing bands going this way, going the horizontal direction with a radius of x, it is covering some of this portion, and going all the way around covers some of the portion, but I need it cut off between 2 to 3, which is technically, I guess, what the bounds do. Just wrapping my mind around that is a little bit rough. If you make the bands go the other direction, you are covering the surface, but you need from 2 to 3 to go away. But if we use bounds of 0 to 2, that does work. And so you're kind of compensating this region by going the other direction and cutting off part of it that way. And then you can use a radius of x to go in, which might be the answer, sadly, to our number 57, even though I don't want it to be. So I'm going to play around with 57. You guys have the test review. Now that my book is hopefully somewhat working, just in case you don't have a book, let me open the first page of the test review so you guys can be working and I'm not wasting your time. Those of you that already started working, go ahead and keep working the answers. Well, let me just get you guys to page 419. Aryan was asking what was going on page 419, why I'm giving you guys like weird problems. 419. I think these are like the AP multiple choice or the AP practice that we didn't get to in class. Of course, now the book stops working. Go team. Sorry guys, it's coming. Come on. If I sweet talk it, will it obey? Yeah, my dog doesn't either. Okay, come on. Come on, come on, come on, come on. So sparkle tonight. Okay, there we go. I can zoom in, I think, just a little bit. You guys can still see it, right? All right, here we go. If you guys want, it's the beginning of the review. And this is the AP practice. We didn't do any of, oh, wait. We did one of these together in class, didn't we? Oh, yeah. No, we definitely didn't do this one, though. Okay, let me freeze the screen. Shoop. I'm going to go ahead and take pictures and post in your Google Classroom, so those of you guys with phones, you can zoom in a lot easier. But for right now, that should definitely fill our time, right? Remember, reviews. Do you have to write questions or directions? No, just go for it. Oh, I just got rid of 57. I heard my name, sorry, yeah? You can use the one on the podium. He's being wonky, but I think my math was a little wonky too. It's on the front podium. Okay.